Okay, good morning student. Today we will learn indeterminate form of limits. Basically indeterminate forms are those form which we can't find by direct method, which we can't solve by direct method. And in mathematics we have generally we are facing some indeterminate form. We have six type of indeterminate form. One is 0 upon 0, other is infinity upon infinity, 0 into infinity, infinity minus infinity, this is infinity, infinite minus infinite, 0 to the power 0, 1 to the power infinite, and infinite to the power 0. Sorry, we have seven types of indeterminate form. uh, Indeterminate forms are generally create when we are solving the quotient type limits of the function. For example, let me take a function limit x tends to a. This is the limit x tends to a fx upon gx. Okay. uh, in this function, if we have if when we tends x to a and the limit of fx tends to 0, suppose that limit of fx tends to 0, then limit of fx tends to 0 and limit of gx tends to 0. In this case, this is the indeterminate form, and we can't solve it. We can't solve the 0 upon 0 by direct method, and we can't say that 0 upon 0 equal to 0 and 0 upon 0 equal to infinity, etc. Similarly, uh, after putting the limit x tends to a, we can find this type indeterminate form, this type indeterminate form, this type indeterminate form, and similarly this type indeterminate form for a function. For solution of the indeterminate form, we are using L'Hopital rule, which is state that the theorem state that under any certain condition the limit of the quotient 0 fx upon quotient function fx upon gx is determined by the limit of quotient of derivative. It's mean if we if we find the first time derivative of numerator and denominator, and then we find the limit of the function, then the limit of the function is same like the limit of this function. Okay. Generally the indeterminate form, generally the L'Hopital rule state that first is limit x tends to a fx equal to 0. Second, limit x tends to a gx equal to 0. Third case is both the function are continuous at x equal to a. Both the function are continuous at x equal to a. Fx and gx are continuous at x equal to a. And fourth condition of L'Hopital rule is f dash x and g dash x exist at x equal to a. Okay. And if all the conditions are satisfied by the function fx upon gx, then we can find the limit of the function limit x tends to a fx upon gx if we find the indeterminate form 0 upon 0 and infinity upon infinity. Only for two indeterminate form we can use L'Hopital rule. Then it is equal to limit x tends to a f dash x and g dash x and it is also equal to limit x tends to a f double dash x and g double dash x and so on, equal to both are exist f to the power n dash n time differentiation of x and f g to the power n time differentiation of x, both are exist. Okay, this is the basic rule and basic method of L'Hopital rule for solving the indeterminate form. Okay, let us take an example. for solution of the indeterminate, for using the L'Hopital rule for such type function, let us take an example. A basic example is, suppose that we have a function x tends to 0 sine x upon x. Suppose that this is a function sine x upon x. In this case, this function is fx and this function is gx. Okay, when we take x tends to 0, then sine 0 equal to 0, and in denominator we can find 0. Then the value of this function, the form of this function is 0 upon 0. This is the form of this function. It means this is indeterminate form, and denominator is gx and numerator is fx. Fx is continuous and gx is also continuous. Fx is differentiable and gx is also differentiable, and the derivative of gx does not equal to 0 in this formula. G dash x, g dash a not equal to 0. Similarly, here is g double dash a not equal to 0, g to the power n dash a not equal to 0. So the derivative of this, the derivative of x with respect to x is 1, and it is not equal to 0 at x tends to 0. So we can solve it by L'Hopital rule. L'Hopital rule says that if we have a indeterminate form 0 upon 0, then we can differentiate numerator and denominator separately, and then we can find the limit of this function. Then limit x tends to 0, differentiation of sine x is cos x, and differentiation of x is 1. It is equal to, when we apply 0 here, then cos 0 equal to 1, then it means the limit of this function is 1. The limit of this function is 1. Okay, this is the basic and very simple example of L'Hopital rule. Okay, let us take another example in our next lecture. Okay, thank you.